All right, lesson 3 from Unit 1. Explore. Students will be able to solve linear equations with rational coefficients by multiplying the least common denominator to clear fractions. I mentioned that a little bit before, so now we're officially going to do it. You can find more of that in 1.4 in the algebra book. So, in an expression, adding and subtracting fractions requires using the LCD to convert fractions in the problem to have the same denominator. This can be done with equations also. So in expressions, you need to convert, okay? In equations, you can, but it's very time consuming. So when you have an equation, there is a way to eliminate the fractions before performing the operations. Most students find this method worth learning because it saves time and reduces errors. The first step is the same. You still need to find the LCD. It doesn't avoid that skill, okay? But the good news is when you find that, you use the LCD to multiply each term to eliminate all the fractions. So then the rest of the process can be done without using fractions. I'm going to sneeze. Excuse me. Goodness. All right. So let's look at this problem here. This is an equation. The ones we did in the warm-up were all, they were expressions. They didn't have anything on the other side. So I sometimes put an equal sign, but that doesn't make it an equation. Look at the practice for just a second. Sorry about the mess. But see how this right here, that's still an expression just because I added a little equal sign. I probably shouldn't have done that, but they're expressions. There's nothing on the other side of the equal sign, okay? Now there is something on the other side of the equal sign. So these are now officially equations. And because they're equations, you want to eliminate all the fractions, then solve for x. It's just easier that way. I don't want to take the time to convert all these to an LCD. Okay? But what I do want to do is still know my LCD so I can eliminate the fractions. Okay. So a 2, let's see, there's a 2 and a 4. The 4 doesn't go in the 6, but if you try to find the lowest thing that they go into, they certainly would go into a 24, but don't they all go into a 12? So I'm not sure how. So that one rule I was telling you about, that's a factor. Those are factors, and this is a factor. So that one rule says when they have a factor in common, use that one once, and then every one of the other ones that are not in common. So that would make your 12. Okay? That's a system that works every time. All right, so what you're going to do is multiply each term by the LCD 12. Okay? Multiply that fraction by a 12. So right here you can see that top number is going to be multiplied by 3 and then divided by a 4. Okay? So some people sit here and take the 4 out of the 12 and get a 3. 3 times 3 is 9. Some other people sit there and go 12 times 3 is 36 divided by 4 is 9. So either way you're getting this 9 from this right here and don't lose the x. Okay? 12 times 7 reduced by 2. So you can go 2 out of the 12 is 6, and 6 times 7 is a negative 42. Or you can do it this way, whichever way. That should turn out to that. And then 6 into 12 goes twice. 2 times 5 is 10. So that takes this really ugly problem with all these fractions and turns it into this one right here. Okay? So we need to then move the 42 to the other side by adding its opposite. So that makes it go away. Whatever you do to one side, you do the other side. Add it over here. Combine like terms gets you the 52. Sorry, it's so small. And the 9x is left, so you're dividing by the 9. 52 divided by 9. And, not divisible by 9 or 3. 5 times 2 is 7, so that is my final answer. Okay? So let's try that again. Denominators, 3, 2, and 6. So 3 goes into 6 and 2 goes into 6, so I can use a 6. So I want to multiply each of the terms, even the ones that don't have denominators. Remember, this is an equation, so every term in the equation needs to have the same thing done to it. One thing you do to one thing, you have to do to all of them to keep it equal, to keep this side equal to this side. If you touch it, you need to do it all the same way, okay? So 3 into 6 goes 2. 2 times 2 is 4. Okay. 6 times negative 2 is 12. Nothing to reduce it by. 2 into 6 goes 3. 3 times 3 is 9. And 6 makes it 1. Yes. Okay. Just checking. Did that kind of fast. That makes the 4. That makes the 12. That makes the 9. That makes the 1. Okay? However you want to write it down, you need to get to this step here. Then once you're in that step, you can, I like to do it this way. 4x minus 12 equals 9x plus 1. So I'm going to move the 12 over. And then I'm going to move the 9 over. Okay, and then let's see, this side's going to be 5x equals, what, 13? Yep. Divide by negative 5, divide by negative 5, x equals negative 13 over 5. Okay? All right. That next one has a lot going on. It says, for when there is a distribution and fractions, there are two choices. Okay, two different ways you can handle this one. I'd like to recommend that you don't distribute first. Okay, you can. It just makes numbers really, really big. Or just use the LCD of the term on the outside. So the LCD of the term on the outside, the terms on the outside is 2. Okay. So it's much easier just to use a 2 and to just clear some of the fractions here. So if you multiply this by 2 and this by 2, you're going to get right here. You're going to get the 3 and the 6. Okay? Then you can distribute just the 3, not the whole fraction, all right? And when you distribute it, remember it's over 1, so you multiply across the top, and you're going to get 15 over 9. 15 over 9 can reduce, okay, because you can take the 3 out of everything and get 5 over 3. Oh, I forgot to put my X in. Oops. Put that on my paper here. I dropped the little X. All right. And then this one, 3 times 4 is 12 over 27. 12 over 27 equals what? Well, let's see. Take the 3 out of this. Let's get to 9. So that's 4 over 9. Okay? That gets you the 6. Still. All right. Now, I still need common denominators. Okay? So I'd have to do it again. So that's the problem with not clearing all of them at one time. Because now I got to clear them again, which is a 9. So I'm multiplying this by 9, this by 9, and this by 9. So let's go back and do it the other way just to make sure we like it that way. So 3 over 2 times 5 over 9x plus 4 over 27. See, these are really big denominators, though. do you want to have to find the denominator of 2, 9, and 27? So 9 goes into 27 3 times. So you can use the 27 for the 9, but you can't use it for the 2 because it's not even. So 27 times 2 is 54. You'd have to clear them by 54. Holy moly. And this one by 54. Can you do them all at the same time? Let's see. Solve. Distribute, then clear. No, you'd have to clear. Okay, that's not going to work. Sorry. So that I was... I know you needed a third way, but that was going to be a third way, and it's just not possible. So go back up here. It says when there's a distribution of fractions, there are two choices. Distribute first. Distribute first. So don't clear anything first. Distribute first. So let's write that down here. 3 over 2, 5 over 9, 4 over 27 equals 3. So distribute first. So this times this, so that would be 15 over 18x plus 12 over, what did I say that was? 54 equals 3. All right, that's distributed first. Now I need the LCD of 18 and 54. See how hard this gets? I don't mind doing it twice if the numbers stay small. And I have all these steps to do it with. But let's see, 18 is what? 2, 3, and 3. 54 is what? A 6 and a 4, which is a 2, a 3. No, I mean a 6 and a 9, right? 6 times 9 is 54. Okay, 6 and a 9. All right, so that means they have all of these in common. 2 times 3 times 3 is 18. Times 3 would be the LCD. It is 54. Okay, 18 does go into 54. So, I mean, who knows that? 12 over 54. So that means we need to multiply this one, whoops, and this one by 54. I'm not liking this way, but that's, all right, so this goes into this 3 times, so that's 45x plus 54, 12 equals 54, whatever 3 times 54 is. 162. The numbers just get really big this way. Minus 12, 45x equals 162 minus 12 is 150. 150 divided by 45 divided by 45 is a run on 3. So I can't do that. So how about dividing it by 15? So that is 10 over 3. So you get the same thing. It's just, I like this way up here because it stays nice and small. So, I like just clearing the outside. Just clearing the 2. Okay? Then you're distributing a whole number. Then you are getting an LCD again of 9, multiplying it all the way through and reducing to that. And then you're just moving the 4 over, and then you're dividing by that, and then you're reducing. Okay? So either way,